Hi, my name is Philip. Welcome to another video. Today I will explain the CMRules algorithm. It is a data mining algorithm that we use to analyze the sequence data. So if you have the data that is like a sequence, you can use this algorithm to analyze and find patterns in your data that will help to understand the data. So by the way, this is my website, and you can also find the code and the data set for this algorithm in the SPMF software, which is open source. You can download to try what I will explain today. So let me do some brief introduction first. Nowadays we have a lot of data in databases for the company, the business, the government, and so on. And there's a need to analyze the data to find the interesting patterns, to learn something about the data, to get some insights. There's a subfield in data mining we call the pattern mining. The idea is to use algorithms to analyze the data and find some patterns that we think are interesting, that will meet some constraints. So, an important type of data that we can analyze, there are many types like graph, sequence, and so on. But one important type that I will talk about today is the sequences. So today I will explain how to analyze the sequences to find some patterns we call sequential rules. And I will explain a little bit how one algorithm works called the CMRules algorithm. So let's start. So first, let me review some basic definition. If you watch my other video, you probably know already, okay? But first, what is a sequence? What do we mean by this, okay? Or we can also call a discrete sequence. A sequence, it is some list of symbols that has some order. Let me show you some examples. So for example, here I have a sequence of items that have been bought by a customer. For example, we have some people buy the computer, then buy a monitor, and then buy a router, and so on. So this is a sequence of items that some people have bought in a store. Another example is a sequence of words. So for example, if you read a book, the words follow some order that makes the sentences. So for example, where followed by are you going? Okay, where are you going? It is a sentence, but you can also think about this as a sequence. So sequences are found in many applications or domains. It could be the sequence about shopping, the sequence of words, or it could be sequence of alarms in a computer's network or system, and so on. Now let me introduce some more definition. What I will call an item. An item means some symbol or events that will appear in a sequence. So let's say we continue with the example about shopping. I have a set of items I will call I, that will be all the items that the customer can buy in a store. So for example, here I say I is A, B, C, D, E, F, G. Those are the different products we can buy in a store, maybe. So A will be for apple, B for bread, C for cake, D for dates, E for eggs, F for fish, and G for grapes, for example. So now we have these items, okay? Let me give you more definitions we need, okay? Another definition is item set. Item set means sets of items. For example, you buy a set of products together. So here, the item set ABC together, it is a set. That means you buy apple, B for bread, and C for cake together. So it is an item set with 3 items. And another example, the set DE, it is an item set with 2 items, like dates and egg, for example. So something I should say is that an item set cannot contain the same item twice. So for example, you cannot have an item set like AA, A, B, C. Okay, it is forbidden to have the same item like 2 times A inside an item set. An item set is a set. Okay, so each element cannot appear more than once. So now, formally, we will define what is a sequence. Okay, I explained already in the introduction, but now I want to give a more formal definition. So we say a sequence S is an ordered list of item sets x1, x2 to xn, where each x, x1, x2, xn is a set of item, a subset of I. Okay. So here, for example, we have a sequence. Let's look at an example to make sense of this. So we have a sequence A, B, means apple and bread together, followed by C. So that means if you buy apple and bread, then you will buy the cake. Another example is A followed by A followed by C. So if you buy apple, then you will buy also cake. So these are some sequence of items, like the purchases in a store. So let's continue. Now, in this topic, we will want to analyze the database of sequence, what we call a sequence database. Sequence database, simply, it is one or more sequences. So for example, if we continue with the example about shopping, let's say you have many customers in a store. So each customer could be a sequence. And then, since you have many customers, you have a database of sequences. So here I have a table with 4 sequences. 1, 2, 3, 4. 1, 2, 3, 4 is the names, the ID of these sequences. So for example, customer 1 bought A, followed by ABC at the same time, followed by AC, apple and cake, then dates, then cake and fish, and so on. Then we have another customer, and so on. So this is the type of data we want to analyze. So if we want to find the patterns, we want to find patterns in this that will tell us something, like if you buy apple, then later you will buy the cake. Or if you buy this, then you will buy that after. Okay, so we would like to find some patterns that will reveal some strong relationship between the items in the sequence to help us to understand the data, or maybe to take some decision. Okay. So one way to do this is to do the sequential rule mining. That means you have a database of sequence and you want to analyze this database to find some patterns that will be some kind of rule. If you buy this, then you will buy this. Okay. So let's define this in more details. So our goal will be to find some rules in some sequences. So I will talk about sequential rule, or more precisely what we call the partially ordered sequential rule. So a sequential rule will be a rule that has the form x imply y, which means if you buy x, for example, you will buy y, where x and y are some item sets that have no order and must not be empty, and also x and y must be disjoint. They cannot overlap. Okay, they must be different. So let me explain this with some example. You will see it's very easy to understand. So here I have one example of sequential rule. It is AB imply FG. So what does it mean? On the left you have an item set AB. It means if you buy AB in any order, you could buy BA or AB. It doesn't matter. Okay. Then, after this, you will buy F and G, or G and F. Okay, the order is not important. But what is important is AB appear before F and G. AB can be in any order, or FG in any order. This is what we call a sequential rule. Okay. Let me show you more details about this. So, here I have some other example. Let's look at this rule. AB imply A. So that means if you buy apple and bread, you will buy apple. So this is not a sequential rule because, as I said before, the left side of the rule and the right side cannot contain the same item. So here we have A on the left and A on the right. So this is not correct. Okay, we don't want to find this. So this, we will not consider this. Another example that is incorrect is empty set, nothing, imply F. This is also not a sequential rule, because a sequential rule, the left and the right sides must not be empty. Okay, so this just to make this clear. So how can we find the interesting sequential rules in the data? To find the good sequential rules are interesting, we'll look at two measures. We call the support and the confidence, or the sequential support and sequential confidence, to be more precise. So the support of a rule X imply Y will be the number of sequences where X appear before Y, divided by the total number of sequences. So that means how many times the rule appear in the database, okay, the proportion. Another measure we'll use is the confidence. That means like the conditional probability. So the confidence of X imply Y will be the number of times of sequences where X appear before Y, divided by the number of sequences that have X. So I will show you this in more details with some example after. So then, the task. We want to find all the sequential rules that have a support and confidence that will be no less than some minimum threshold set by the user, the minimum support and minimum confidence. So let me show you this with an example to make this clear, okay, because maybe now it's not so clear. So here we have an example, a complete example. So on the left we have a sequence database, similar to what I have shown to you before. Okay, we have 4 sequences, and then we need to set the 2 parameters. The minimum support means the frequency. Okay, we want to find the rules appear in at least 50% of the sequences of the database. So we set 0.5, and we want the confidence to be at least 0.5. So based on this, we will find the rules. This is the result on the right. So we find many rules that have the support at least 0.5 and the confidence at least 0.5. So now let's look at some rules to make sure we understand this clearly. Let's say we take the third rule, AB followed by EF. Okay, so we want to calculate the support of this rule. So we need to find all the rules where AB appear before EF in any order. So here we have AB followed by EF, so 1 time. In the second sequence, we have AB followed by EF also, so 2 times. And in the third sequence, we have also AB followed by EF. Okay, so EF can be any order, it doesn't matter. So 3 sequences out of 4, so that means 0.75. This is the support. Now for the confidence, we need to look how many times AB appear before EF. So this is 3 times, we calculate already, divided by how many times we have AB, how many sequences contain AB. So AB appear in 1 sequence, 2, and 3 sequence. So 3 divided by 3 means the confidence is 1. That means every time you buy AB, you will always buy EF after. So that means 100% the confidence. Okay. So this is what we want to find. Okay. We want to find the sequential rules in the database, as you can see on the left, given some parameters that are set by the user. So here I did not show all the rules. Okay. I show some of them. So now, how can we do this? It is not an easy problem, actually. Okay. So let's say that you have R distinct items in a database. The items like bread, cake, and so on. Okay. Then we could make the proof that the number of possible rules in the data will be exponential. It will be like this. Okay. 3 to the power of R minus 2 to the power of R plus 1, and so on. So, if you have many different items, the number of possible rules will become very, very large. So we don't want to just explore all the possibilities. We need to define a better algorithm. So today I want to explain to you one algorithm called CMRules. It is the first algorithm for this problem. So the key observation for this algorithm is that all the sequential rules must also be association rules. Okay. So I assume that you know already what is an association rule. I will explain again briefly, okay, after. But if you know what is an association rules, now you can know that the sequential rules are a subset of the association rules. So this is an important observation on which this algorithm is based. So CMRules will use this idea to find the sequential rules. First, it will apply an association rule mining algorithm like a priori to find the association rules, and then CMRules will do another step. It will eliminate the association rules that are not the sequential rules. And finally, it will find all the sequential rules. So let's look at this in more details. So first, maybe I think I need to review briefly what is association rule mining, because maybe you don't remember, okay, or you did not watch my other videos. So association rule mining, it is a data mining problem. Okay, the input is a transaction database. A transaction database is similar to the table you can see on the right. Each transaction is a set of items. That means a subset of I. Okay. So for example, in a transaction 1, we have some people buy A, B, C, E, F, G. Transaction 3, we have A, B, E, and F, and so on. But here, I want to make you pay attention to this, okay? These are not the sequence. There are no order here, okay? This is not a sequence. All these transactions are set. There are no order. So transaction 1 means some people buy A, B, C, E, F, G. But there are no order here because there's no time. Okay, those are not the sequences. Then, in a transaction database like this, we can find association rules. Okay, an association rule is very similar to a sequential rule, but here the key difference is there's no time here. Okay, no order. So an association rule X imply Y means that if you observe X, you will also observe Y. But there are no order. It does not mean after or before. It means if in a transaction you have X, you will also have Y together, but not before or after. There are no time in this problem. So, for example, we could find some rules like A, B, C imply E. Okay, the second rule. So A, B, C imply E means if you have a transaction that has A, B, C, it will also contain E. Okay, normally. But again, there's no time in this. Okay, it does not mean after or before. It means together. If you have ABC, you will also have E together. Okay, simply. So to find association rule, also we have the concept of support and confidence, like for the sequential rules, but here there is no time. So if we take a rule like A implies CEF, we say the support is 0.5 because ACEF appear in 2 transactions out of 4. Okay, so 0.5. For the confidence here, A imply CEF, we have how many times we have ACEF? It is 2 divided by how many times we have A. So A is 3 times. So 2 divided by 3 will be 0.66. Okay, and so on. So this is the main idea about association rule mining, to quickly review, okay, about this, in case you don't know. So now, there is some relationship between association rules and sequential rules that is interesting. If you have a sequence database S, okay, so here, I don't want to confuse you, okay, before I use S for the sequence, but here S means the database, okay, so don't be confused by the notation, okay, I changed the notation here a little bit. So here, if we have a sequence database S, if we remove the time or the order for the sequential order, we can obtain a transaction database S prime. And then each sequential rule in S will have a corresponding association rule in S prime. And we could make the proof that the support of the association rule will always be more than the support of the sequential rule, the corresponding sequential rule. And the confidence will be the same, will be greater or equal to the confidence of the sequential rule. The reason why it is like this, okay? Because in association rule mining, we don't care about the order, so the support will be more than the sequential rule. In sequential rule, we have the order, so because of the order, the sequential rule will always appear less than the association rule, or at least the same number of times. So, based on this, I will explain to you the CMRules algorithm. It is really simple. You will see with the example. Okay. So the input will be a sequence database and the minimum support and confidence, and the output will be all the sequential rules. So first, what we will do, we will consider the sequence database as a transaction database, and then apply an association rule mining algorithm to find all the association rules. Then, after we find the association rules, we scan the sequence database to calculate the support and confidence as if it is a sequential rule. Then this will allow us to eliminate the association rules that are not the sequential rules. And finally, we find the set of the sequential rules by doing this. And that is the end of the algorithm. Okay, really simple. So I will not make the proof about this. It is in the paper. Okay, but I want to show you an example to make this very clear. So here we have a complete example. On top I have a sequence database, okay? So here it is a database like I have presented before, okay? Not the same, but another database with sequences. Here I did not follow exactly the same notation, okay? Instead of curly brackets for the item set, we use the parenthesis here, okay? But still it is a sequence, okay? It is the same thing. So first, step one, what we do, we take the sequence database and we remove the temporal information or ignore. We don't need actually to remove. Then we get a transaction database. So for example, the first sequence has A, B, C, E, F, G, E. So this will become the transaction A, B, C, E, F, G without the time or the order, okay? So we do this for all the transaction, and then we can apply the association rule mining algorithm like a priori and so on to find the association rules. So we use some existing algorithm to do this. And after we have done this, we compare the association rules with the sequences we had before to do the filtering. And this will allow us to calculate the real support and confidence of the sequential rules when we consider the order, okay? What we call the sequential support and sequential confidence. And this will give us the set of sequential rules in the end. So what you can observe is that if you take a rule like AB, the association rule, the support and confidence will always be at least greater or equal to the support and confidence of the sequential rules. This is a property that I have explained before. I will not do the proof, okay? So that algorithm is very, very simple, okay, actually, because we use the existing association rule mining algorithm. Now, if we want to do some implementation of this, we can do some small optimization, actually. When we want to calculate the support of sequential rule X and Y, we could just compare X imply Y with all the sequences. But it will not be a good idea, because X imply Y maybe does not appear in all the sequences, so this will waste a lot of time. So one optimization, briefly, okay, is when we find the association rules, we remember the ID of the sequence where the association rule appear. And then when we want to calculate the support of the sequential rules, we only check the sequence that contain the rule. We don't need to check the whole database. So this can speed up the algorithm by more than 50% in some experiment we did. Also, another thing, we don't really need to find all the association rules and keep all of them in memory before we filter them. Actually, as soon as we find the association rule, we can directly try to decide, is it a sequential rule or not? We don't need to accumulate all the association rule in memory. So this is another optimization that will reduce the memory for this algorithm. Now, if we want to analyze the complexity of this algorithm, step one, we need to convert the sequence database into a transaction database. So this is done in linear time. Step two, we need to do association rule mining. So first we find the frequent item set. So the complexity, I will not go into details, but it will be something exponential normally, okay, for the number of item sets. And then after that, we need to generate the association rules, which is not very costly. We can mostly ignore. And then after this, we need to scan the database again to calculate the support and confidence of the sequential rule. In the best case, the association rule only appear in the minimum number of sequences to be frequent. But in the worst case, all the rules appear in the whole database, and it will take more time to scan the database, so it will not be so fast. So this is just a rough idea about this. If you are interested by more details, you could look at the paper also. So in conclusion, in this video, I explained one algorithm for sequential rule mining called CMRules that will find the sequential rules that appear in many sequences, like to analyze the shopping data and so on. CMRules, it is quite a special algorithm because it can find the sequential rules and association rules at the same time. And also one advantage is that it can reuse the code of the existing association rule mining algorithms. But nowadays there are some more efficient algorithms that have been designed, such as rule growth and ER miner and so on. Okay, so CMRules is not the best algorithm in terms of speed, because sometimes the number of sequential rules can be much smaller than the number of association rules. So in this case, in these cases, CMRules will not be so efficient. Okay. So if you want to try CMRules and these other algorithms, you can check the SPMF website you can find online, and you will get the code, the data set, and you can use this on your data or to do the research. You can also modify the algorithm to improve them or do other topics also for research. So again, thank you for watching this video. Okay, bye.